Today's daily go problem of the day is Fruits in the Baskets, Part 3, number 3479. For this problem, we're given two integers array fruits and baskets, each of length n, where fruits of I will represent the quantity of the ith type of fruit, and baskets of j will represent the capacity of our jth basket. So from left to right, we want to place our fruits according to these three rules. Each fruit must be in the leftmost available basket with a capacity greater than or equal to the quantity of our fruit type. Each basket can only hold one type of fruit, and if a fruit type cannot be placed, it remains unplaced. And our goal is to return the total amount of remaining unplaced fruits. So let's go ahead and jump into kind of looking at the examples of this problem. So same problem as yesterday. Basically, we're going to take each fruit starting from the left and going to the right, and we're going to say, okay, 4. Can we put 4 in the first basket? No. Can we put 4 in the second basket? Yes. So 4 will go into the second basket. Now we're going to look at 2. So 2, can 2 go into the first basket? Yes, it can. So 2 will go into the first basket. Now we have 5. So can 5 go into the third basket? No, it cannot. So that remains unplaced, and we will return 1, as that is how many fruits remain unplaced. So for this problem, it's the same problem that we did yesterday. However, obviously, there's a reason why this is fruit baskets part 3. And that is because we got to look at our constraints down here. So baskets of I is now going to be less than or equal to 10 to the 9th. So that's going to be 32 bits long. Meaning, if we have a shit ton of baskets and fruits that are 32 bits long, it's going to take a long time to manually go through each and every one of these. And that's kind of where that leaves us with this problem. We need to find the optimal solution to solve it. So what we're going to do is we are going to use a technique called the square root decomposition. And this is basically going to take our baskets array. So our baskets array, for example, is 3, 5, 4. So we're going to take 3, 5, and 4. And we are going to divide our baskets array into square root of n blocks. So in this case, the square root of n being 3, so the square root of 3 is going to be super tiny. So we don't technically or necessarily have to do it for this problem. But we can say, let's say, for example, our array is of length 4. Our basket's array is of length 4, so we could take the square root of 4, which is 2. So we're going to divide this array into 2 blocks. Here's our first block, and here is our second block. Now, with our 2 blocks, we are going to take our input fruit. So for this example, we have our input fruit of 4. I have an F here to represent that. So when our fruit is equal to 4, we are only going to want to check the block that could possibly accept this fruit count. And we'll do this by keeping track of the max of each block. So the max of each block will allow us to determine, okay, can our fruit fit here? So the max for this one's 5, the max for this one is 4, right? So what we're going to do is say, okay, our fruit is equal to 4. Let's look at our first block. Okay, our max is equal to 5. Our fruit could fit in this block theoretically. So what we're going to do is we're going to take 4 and compare it to the first item, and then we're going to take 4 and compare it to the second item. Or not necessarily compared to the second item. If it could fit in this first item, we'll put it in the first item. Otherwise, we'll put it in the second item or third item, however many items are in each block. Same thing, for example. So let's say 5 has been used. We'll update our max to be equal to 3, because now that is the new max of this block. Okay, fruit is equal to 4. We'll check 4 versus 3. Okay, 3 is too small. The fruit can't fit in this block, so we skip it. Okay, 4 and 4. All right, the fruit can fit in this block. So we're going to check it versus the first item, and boom, we found our match. So now we can fill that in, update our max. Now, let's say, again, we have fruit is equal to 4. We check our first block. Nope, can't fit. Check our second block. Nope, can't fit. Well, there's no reason to check each individual item because we know 4 can't fit. So we can add 1 to our unplaced count. So yeah, that is how you theoretically solve this problem. So let's go ahead and jumping into coding that solution. So first thing we're going to do is initialize an integer n, which is going to be our baskets.length, simply because we're going to use the square root of n to mark off our blocks. We'll then also have an integer m, which is going to be our value of square root of n. And we want to make sure that this is an integer, not a double or a float. So we're going to have an int, and then it's going to be math.square root of our n value. Next thing we're going to do is determine our sections or our blocks sizes. And so our section slash block sizes are going to be integer section is equal to n plus m minus 1 divided by m. This is going to allow us to divide our baskets array into an even amount of sections of n plus m minus 1 divided by m size each. Now, with that many sections, and we're going to want to keep track of the max of each section, we're going to have an integer array called our max value, and it's going to have a new integer array of length section, because there's a section amount of sections. And we're going to arrays.fill this max value array with zeros, because currently that is the max value of each block. Now we're going to do our for loop to populate this max value array. So for each integer I is equal to 0, as long as I is less than our sections, or sorry, as long as I is less than n, I can increment. And we're going to update our max value to be I divided by m. That allows us to calculate our section. This is going to be our I, this is going to be our m. So I divided by m is equal to our math.max value of max v of I divided by m. And then we're going to populate each one of these with the baskets of I. And the reason we're doing this way is baskets of I will always be the max of each block. So now that we have populated that max value array, we are going to traverse each fruit, and for each fruit that fits into a section, we will traverse that section. So for each integer fruit in fruits, we are going to say, okay, define an integer sec, which is going to be short for sections, and an integer unset, which is going to be our count of how many values are unset. And we'll update this to be 0 if we can place it. Otherwise, we'll leave it as 1. So for each section is equal to 0, as long as our sec is less than our sections, then our sec can increase. So if our max v of sec is less than fruit, then we're going to want to continue. So what is this checking? If the max value of the current section we are looking at is less than the amount of fruit needed to put into a basket, then we skip this section because there's no numbers in here that can hold that fruit. So we're just going to skip it. Otherwise, we'll have an integer called choose, and this is going to help us choose which section to put in. So our max v of sec will also be equal to 0 because we have identified that we are going to use that bin, right? We know for a fact that the max value of the section needs to be updated because we are going to put our value there. Or we will update it to the max after we put our value into the section. So for each integer I is equal to 0, as long as I is less than our m value, I will increment. So we're going to check. The integer position is equal to section times m plus I. And so if that position value is less than n, and our baskets of position are greater than or equal to fruit and choose equal to 0, meaning that we haven't placed it yet, then we can say, okay, baskets of that position is equal to 0 since we're putting our value into that position. and our choose is going to be equal to 1. We chose a place to put it. Then we're going to say if our position is less than n still, meaning we're still within the array, we're going to update the max value of this section to be equal to the math.max of our max value of the current section and baskets of position. So if we updated the baskets of the position, we need to update the max value. All right. So after that, we are then going to check, or sorry, not check, but we're going to update our unset value to be equal to 0. And then we're going to break out of this loop. That's because if we were not able to place our bin or place our fruits into any of the bins, we would have continued, leaving our unset value at 1. Otherwise, no matter what in this little area / loop, we for sure placed our fruits into a bin. So we can update unset to 0 because we set that fruit and break out of this loop where we're then going to update our count to plus equal whatever the unset value is. And then we're able to return our count. So if we run this, passes our test cases, and if we submit it, passes all solutions. So thank you, and follow for more daily LeetCode solutions.